Okay, what we're going to be doing now, performing a fuel pressure test. Just see what kind of pressure that this particular vehicle holds. Just kind of show you what we got set up. We got our gauge set up to a T. It's just a fitting here, and then it goes into your fuel rail right here to this fitting. Alright, go ahead. Before it was about 50, you're sitting around about 55 right now, pounds of pressure.
But Booker was right there yesterday when
Yeah, good morning, folks. Basically what we're going to talk about now, we explained, we showed you the path, power path, your ground, and kind of how where the relay and the pump was and your fuse. Basically all we're going to explain now is why and how the fuel pump actually operates and how you do it. Basically, it's real simple. First of all, the reason why you have the fuel pump is to build pressure, your fuel pressure into your system or your line. But basically how that operates is whenever you put the key in your vehicle, you just turn it on and your fuel pump cuts on. That's when it turns the switch on. If you can see it right here, just turns the switch on. Like I said, this is where your fuel pump is. So that's pretty much it. Good morning, folks. What we're going to be doing this morning is a bench test, and we're going to do a voltage drop on your fuel pump relay. You can see how we've got it wired here on our relay. Basically what we're going to do, we're going to check a voltage drop here on your multimeter and see if it jumps down any bit here. Let's see here. Okay. It dropped down just about hardly none. Very, very little voltage drop on this. But that's pretty much the sense of it, just a quick voltage drop. Thank you. Good morning, folks. My name is Patrick Petty. I'm a student here at J-Tech. What we're going to be talking about this morning is the fuel system. I'm just going to show you a couple things as far as the path, where your fuse and all is located, the actual fuel pump. Just kind of explain the ground side, the power side, through these schematics here. As you can see here, we're in the PCM. We're right here on the fuel pump relay. Follow this. This is your power path. It goes up to your relay. It goes into the switch side. Or I'm sorry, the coil side. It comes down. That's when it becomes the ground. It goes down, crossed, comes back over here. This is still your ground side. This is where your actual fuel pump is. And this is your power side that goes up to your fuse and to your switch. That's pretty much it. Good morning, folks. What we're going to be talking about this morning now is your fuel sending unit. As you can see here in front of me, this is actual fuel pump out of a vehicle. Basically all we've got going on here, we've got our leads connected to our fuel pump, just connected to our multimeter. Basically all we're going to be doing is checking the resistance, or checking to see if it's operating properly. The way we can do that is this is your float on part of your fuel pump. As we lift it, you can see it lowering on your meter. And drop it. Just tells you that it is operating properly. You can raise it all the way up too. So that's pretty much it. That way you know it's operating correctly. Alright, what we're going to be doing now is just showing the fuel pump power, for your power on your schematics. As we said earlier, you can see the power coming off in your PCM. It goes up here, goes into your relay. Basically how you want to see if it is operating correctly. Down here is your fuel pump. What you do, you take one lead on one side of the fuel pump, and the other lead on the other side. There's connectors on your fuel pump, and you can turn your switch on and off by turning your key to see if it is operating correctly. Alright, what we're going to be talking about now, or basically just do a little bit of show and tell about the fuel injectors and how they operate and how they're powered, and just kind of talk about the paths of them also too. As you can see here, the pink represents the power. It comes out of the fuse block, goes down to your injector. You can see each individual injector are powered by one power source, and this is your ground side that is grounded to the PCM, but it is ground side controlled because you can see each individual injector has its own ground, so it's ground side control. But that's it. It's just yellow for your ground and pink for your power, and these are your injectors. Okay, what we're going to be doing this morning is what we call a sound test. It's going to be for your injectors. Basically, we're just going to check one injector here this morning. The tool that we're going to be using is just a stethoscope. I've got one of my classmates here. He's going to crank the vehicle, that way I can tell and hear the click if the injector is operating properly. If it is a thud, like a dull sound, and knows that it's not doing its work that it should be. Okay. So what we'll do, if you can look down here, we're just going to take it and put it on your injector. You want to make sure that you're on the actual injector and not touching any of the metal, like for instance like your fuel rail or anything like this where you're fitting. You want to make sure it's just on the injector. Okay, go ahead and crank it, Cole. And I do hear it clicking, so it is operating properly. Okay, what we're going to be doing now is a NOID light or NOID test. We've got a test light plugged up to one of the injector plugs here. Basically what we want to be looking at for the pulse in the light once he cranks it. Go ahead, Mitchell. You can see it's a steady pulse, so it's operating properly. And it's pretty much what you want to be looking for.
Hey folks, Patrick Petty here. Today we are going to be taking a look at the voltage that is going to be present at the injector. So what we did here basically is we back pinned the two wires on the injector harness, and we're going to crank the car, and with our leads hooked up to our voltmeter, it's going to show us just how much voltage is getting to that injector. So go ahead and crank it. As you can see here, we're reading just shy of 0.7 of a volt. So that's how much voltage that injector is getting.
Okay, before we did the power on the injector, now we're doing the resistance. You can see we're just pretty much hooked up to the actual injector. You see the reading is 0.3, 0.2. That's the actual resistance on that injector. If you want to do each individual one, you need to make sure that you unplug each injector and check each individual injector. Good morning, folks. What we're going to be doing this morning is a power balance test on the injector. Basically what we're doing, we got our tool set up here. We got your gauge. You got it hooked up to the injector. Pretty much you just want to record what pressure is on the reading right now. The way you do that, you just kind of cycle the key to build up that pressure. If you can look at it, it's sitting around about 50. To perform this test, you just go to your tool and you just hit the button, and you can actually hear the injector pulsing. You hear it working now. Look here on your gauge, you're sitting at around about 18 psi. So you see where it dropped. All